Hello my dear students, let us take some more examples. The direct shear test was conducted on a cohesive soil sample and the following results were obtained. Normal stress is given 150 and 250 kilonewton per meter square and shear stress 110 120 kilonewton per meter square. What would be the deviator stress at failure if a triaxial test is carried out on the same soil with the cell pressure of 150 kilonewton per meter square? Okay, so what it is asked to find, first you have to, it is not mentioned to calculate what is C and phi value, but you have to calculate the deviator stress at failure if the triaxial test is carried out. Okay, this is direct shear test results, normal stress and shear stress. So from normal stress and shear stress, what you can get, you can draw the graph. So from the graph you can get C and phi. If you have C and phi value, you can find sigma 1. Cell pressure is given, that is sigma 3. Sigma 3 is given, so only you have to calculate now sigma 1. How we can calculate sigma 1? We have the formula. We have formula sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. So let us first find what is this C and phi. So how you can find C phi? Either you can draw the graph. From the graph, normal stress versus shear stress. From that graph you can find C and phi value. But here there are only two values. So easily you can use this equation and you can find what is C and phi. Okay, that is left to you. You can draw the graph and find out what is C and phi, or you can solve this simultaneous equation. Like we have the formula tau f is equal to C plus sigma tan phi. Okay, so tau f, that is shear strength, shear stress for the first case, that is 110. Okay, equal to C is unknown, plus sigma, that is normal stress for the first case 150, into tan phi. Phi is unknown. Okay, this is one equation. And second equation, same use the same formula, tau f is equal to C plus sigma tan phi. Okay, now tau f is equal to second value of shear stress, second case, that is 120, equal to C plus sigma is 250. Okay, normal stress 250 into tan phi. So all of you know how to solve this equation, right? So first you make it deduct this minus, use the minus sign. So 110 minus 120, you get some value. C minus C get cancelled. 150 minus 250, you will get some value. So that is only one unknown. You can calculate what is phi. Okay, once if you get the phi, you can substitute any one of this equation and you can find what is C. So what you will get, C and phi is equal to, here when you solve this equation, we'll get C is equal to 93.7 kilonewton per meter square and phi is equal to 5.7 degree. Okay, you just check, cross check this answer whether you are getting the same or not. Once if you have C and phi value, we can use this formula. Sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. Okay, so now alpha we know, that is 45 plus 5 by 2. So that is equal to 45 plus 5 is 5.7 divided by 2. So equal to 47.8 degree, that is alpha. Okay, now we have this value, cell pressure value, sigma 3. Okay, now we have to calculate sigma 1 value. What is sigma 1? Sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. Sigma 3 tan square alpha, sigma 3 is 150 into tan square alpha is equal to 47.8. This is found out, 47.8 plus 2c tan alpha, 2 into C is 93.7 into tan alpha is 47.8. Okay, simplify this, you will get 389.2 kilonewton per meter square. Okay, we have now values sigma 1 and sigma 3. So deviator stress I have to calculate. Deviator stress is equal to sigma 1 minus sigma 3. So substitute what is sigma 1. Sigma 1 is equal to 389.2 minus sigma 3 is 150. So we will get 239.2 kilonewton per meter square. So like this you can calculate what is deviator stress. Okay. Here you have two options. Either you can solve the equation or you can draw the graph. From the graph you can find what is C and phi value. Once if you get C and phi value, you can find what is alpha and you can find what is sigma using this equation. Once you have sigma 1 and sigma 3, you can calculate what is sigma d. I hope all of you understood. Let us take one more example. A consolidated undrained test was conducted on a clay sample and the following results were obtained. Okay, cell pressure, that is sigma 3, is given 200. For three tests were conducted. 200, first case, second case 400 and third case 600. Then deviator stress at failure, that is sigma d, 180, 240, 352. Then pore water pressure at failure, 110, 220 and 320. So what is asked to calculate? Determine the shear strength parameters with respect to total stresses and effective stresses. So here you have to calculate what is the C and phi value also and with respect to the total stresses and effective stresses. Okay, so how we can calculate total stress and effective stress? We have sigma 3 values. Write that sigma 3, 200, 400 and 600, and deviator stress value, that is 118, 240 and 352. Then pore water pressure, that is U is equal to 110, 220 and 320. Okay, now we have to calculate what is sigma 1, major principal stress, that is equal to sigma 3 plus sigma d. Otherwise, why it is sigma 1 is equal to sigma 3 plus d? Because deviator stress we have formula sigma d is equal to sigma 1 minus sigma 3. Okay, so right, in terms of sigma 1 we will get sigma 3 plus sigma t. Sigma 3 is 200 and sigma d is 118, so it is equal to 318. And second case, sigma 3 is 400 and sigma d is 240, so it is 640. Next case, 600 plus 352, 952. Okay. After that, you have to calculate the effective stresses. Effective stresses means you have to deduct the pore water pressure, okay, from the total stress. We have sigma 1, that is 311, 318. Deduct the pore water pressure. So 318 minus 110. Pore water pressure is given here. So 318 minus 110, that is 208. Next case, 640 minus 220, that is 420. Next case is 952 minus pore water pressure is 320, you'll get 632. So if you have sigma 1 dash, same thing you can calculate sigma 3 dash also. How it is? Sigma 3 minus u, deduct the pore water pressure. Sigma 3 is 200, 200 minus 190, that is 90. Next is 400 minus 220, 180. Next is 600 minus 320, it is equal to 280. So like this you can calculate what is total stress and effective stresses. Okay, let us take one more example. An unconfined compression test was conducted on an undistributed sample of clay. The sample had a diameter of 38 mm and length 76 mm. The load at failure was 13 Newton and the axial deformation of the sample 11 mm. Determine the undrained shear strength parameters if the failure plane made an angle of 50 degree with the horizontal. Okay. Now it is asked to calculate shear strength parameter, that is Cu and phi u, because this is unconfined compression test, that's why Cu and phi u. Okay, so what is given here? The length is initial length is 76 mm, that is L naught. Okay, then diameter, initial diameter is D naught, is 38 mm. So first find the initial area, that is equal to pi d square divided by 4. Pi d naught square, that is 8 square divided by 4, that is equal to 1134.1 mm square. This is the initial area of the cross section. And then here the load at failure was 30 Newton and the actual deformation of the sample 11 mm. So the deformation is given, that is nothing but change in the length delta L, that is equal to 11 mm. Okay, now action strain, you can calculate what is strain. Change in the length divided by original length. So strain symbol this. So change in the length, that is delta L 11 mm divided by original length, initial length 76. We will get 0.145. Next, you have to find the cross section, area of cross section at failure. This is at the first stage, initial stage. Now you have to calculate at the failure. So what is that? Area is equal to A naught divided by 1 minus strain. Okay, so this is the formula. It's obtained after the derivation, so you have to remember this formula. Okay, so what is A naught? A naught is 1134.1 divided by 1 minus strain is 0.145. Okay, so simplify this, we will get 1326.4 mm square. This is area of the cross section, and load at failure is given, that is 30 Newton. So unconfined compression strength, compressive strength, what is that? Load divided by area. So QU here, because this is unconfined compression strength, QU is equal to load divided by area. Load is 30 divided by area, that is area of the area at the failure, that is 1326.4. Simplify this, you get this answer. Now after that, what you have to calculate? Now you have Q value. From this you have to calculate what is C and what is phi. Okay, now alpha is given because here it is told the failure plane made an angle of 50 degree with the horizontal, so that is alpha. Alpha is equal to 50 degree. Okay, so we have that formula, alpha is equal to 45 plus pi by 2, correct? So this alpha is equal to 45 plus pi by 2. Okay, so alpha is given, that is 50 and is equal to 45 plus 5 by 2. Okay, simplify this, you will get phi. So you will get phi is equal to 10 degree. After simplify, you will get phi is equal to 50 minus 45 is 5. 5 into 2, it is 10. So phi is equal to 10 degree. Then after this, once if you have phi value, you can calculate what is C. How you can calculate? We have this formula. Sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. So here sigma 3 is equal to 0 because this is an unconfined compression test. In unconfined compression test, C3 is equal to 0. So this entire term becomes 0. So only this term will be there, that is QU is equal to, now so sigma 1 is equal to sigma 1 is nothing but this QU is equal to 0, this term is 0 plus 2c tan alpha. So Cu, that is equal to Qu divided by 2 tan alpha. So Qu is given, that is 0.023 divided by 2 tan 50. Okay, alpha is 50. Simplify this, we will get 0.0096 Newton per mm square. So this is Cu value. So like this, you can calculate what is Cu and phi u values. Okay, in unconfined compression test. I hope all of you understood. Thank you.